It's my pleasure to chair this session. I'm sure a lot more people will come as buses arrive, but since we have another session waiting at 9 o'clock, I think it's better to start it right now. Less than 2 weeks ago, on September 14th, Japan launched the Lunar Explorer SELENE, which is the original name, and nicknamed as KAGUYA. KAGUYA or KAGUYA, there's a controversy within Japanese community. However, this SELENE was launched on board H-2A launch vehicle. And in those days, on the days when it was launched, this organizer of this symposium was just on the finalizing phase of the late breaking news items. But since this is one of the, this is the first of the series of lunar exploration missions in coming years, the Dr. Suresh and other IPC decided this item to be included. So it is happy to have Professor Kato here, who was very busy. He arrived last night at 11:30, and he will get the airplane back tomorrow morning, very early. It's a great pleasure for us to have you, Professor Kato. And Professor Kato received his PhD in 1985 from Nagoya University. And after 20 years of research experience in Nagoya University, he joined into JAXA in 1997. Yes. And at that time, this was ISA still, the former institution for taking care of the space sciences. Since 1999, he has been the science manager or chief scientist of SELENE, this mission, and now is the director of JAXA Planetary Science Division. Professor Kato, please.
Thank you, Professor Yasaka, and thank you for inviting me in this LBN hall. And I'm Kato, that is full name Manabu Kato, and I work in science manager of SELENE KAGUYA mission. Now, Professor Yasaka says 2 weeks ago, our SELENE KAGUYA was launched successfully, and then I show you the SELENE mission briefly. So I start this picture. You know this picture, of course, no. This is a picture in Japanese classical tale. Taketori, it means bamboo cutter stories. And can you see the KAGUYA, Princess KAGUYA? Princess KAGUYA is here. You can see the princess, and this is a vehicle, so-called H-2A rocket and satellite. So this vehicle come from the moon, and they carry the Princess KAGUYA back to the moon. This is a Japanese classical story. Yes, this is a launch scene. You can see the launch pad in the south of Japan Island. So you can see the wave here, and we wait launch. Maybe before 10 seconds before launch. This is our vehicle, H2A rocket, and they have four solid booster. And now main engine start. The liftoff. In this day, very fine day, so we can see the rocket about 3 minutes after launch. Okay, we can see some cloud on the top of the fairing. We can launch KAGUYA successfully in 2007, September 14th, 10:31 or 0 JST, Japan Standard Time. This is launch sequence, liftoff, and separation of satellites. About 45 minutes later, we successfully KAGUYA satellite above South America here. This is outline of KAGUYA SELENE mission. We have 3 orbiters. One is main orbiter, the other is small satellite, relay subsatellite, we called Rstar, and Vstar satellite, we called Vstars. Our mission period is about 1 year. Our mission period is about 1 year. It's nominal, and of course we expect extended missions. They have 3 orbits. One is 100 kilometer altitude circular polar orbit for main orbiter. Other sub-satellite has an elliptical orbit with 100 kilometer, 800 kilometer for Vstar, and 100 kilometer altitude, and 400 kilometer for Rstars. Total mass of our mission is about 3 tons wet mass, and we include science instrument about 300 kilogram, and 2 sub-satellites to 50 kilogram each. Okay, we have 14 science instruments on board, and they are, as you can see already, we will be launched by H2A, our Japanese main rocket, by Tanegashima Space Center. This is the mission profile from launch to nominal observation orbit. And first, at launch here, and we have 2 phasing orbits. At first, we extend the solar cell paddle and high gain antenna, and then so some event will be successfully passed. And then September 19th, Kaguya back to the Earth, and now Kaguya fly here, secondary orbit, and then return to the Earth September 29th. So then they direct to the lunar orbit. On October 4th, maybe October 4th, we plan to insertion of the lunar orbit with a very long elliptical orbit, and maybe 100 kilometers and 14,000 kilometers. So then we reduce the altitude and release two sub-satellites. One is a relay satellite, and the other is Wheeler satellite. So then we settled final 100 kilometer altitude polar circular orbit, maybe October 19th. Oh, this is a Kaguya sequence event, nominal events. This is a nominal date, September 24th, second apogee passage of Kaguya, and September 29th, second perigee passage of Kaguya. Now we check out in this phase, our check out of science instruments. October 4th, lunar orbit insertion phase. First lunar orbit insertion. And October 9th, Rstar, and October 12th, Vstar separation. We will plan. October 19th, lunar orbit insertion, final lunar orbit insertion number 6. Then we plan to check out and science instrument extensions. One is a magnetometer mast extension. This is radar sound antenna extension. And October 30th, UPI, it is terrestrial imager development we planned. After November 1st, we plan to check out science instruments. And maybe December, mid-December, from mid-December, we start steady nominal operations. This is the Kaguya SELENE mission objectives. We have 3 objectives. One is a global survey of the moon, of course, global survey of the moon. This is top priority. It includes comparison of 3D topography, gravity field, magnetic field, and lunar environments. Second is technology development demonstration for future. It has lunar insertion technology, orbital correction maneuver, and telecommunication technology. Third, this is quite important, I think. It's a public outreach of lunar exploration. We on board high-definition TV camera and in Kaguya satellite, then we can broadcast the Earth rise or lunar surface of high-definition movies. This is configuration of Kaguya satellite before separation of 2 sub-satellites. This red shows the science instrument, which on board this side of which side is direction to the moon. Some instrument observed opposite side of the moon. this is our instruments summary, and we have 1, 2, 3, 4, 5 categories. One is to observe elementary composition of lunar surface by these two instruments. The second is the mineral composition of lunar surface by these two instruments. And third is topography of lunar surface by 3 instruments: terrain camera and radar sounder and radar altimeter. And fourth is a measurement of gravitational field of whole moon. Especially this instrument to use is used to measure the gravitational field of far side of the moon. This is gravitation very exact gravitational field of near side we can use. Last category to measure the environment of lunar surface: magnetometer and particle spectrometer, plasma analyzer, and radio science plasma imager. This is KAGUYA in the clean room of Tanegashima Tsukuba Space Center. This is KAGUYA satellite, and it seems it looks like microburst, about 2 meter, 5 meter dimensions. This is examples of instruments. X-ray spectrometer attached here, and the gamma ray spectrometer attached here. This is the scene of thermal vacuum test in Tsukuba Space Center. SELENE, that KAGUYA satellite is standing by the thermal vacuum chamber of 30 meters in diameter. This is sub-satellites, Rstar and Vstar, relay satellite and Rstar sub-satellite. This is maybe Rstar. I think this is Rstar. 2 sub-satellites are almost the same, but small change they have. So this is a relay satellite. This is mass balance test. This sub-satellite has a dimension of 1 meter, 1 meter, 1 meter octahedral prism. Now I show you some science instruments, with some detail. This is the X-ray spectrometer. This is composed of 2 sensor and the electronic box. This is the main sensor of X-ray spectrometer. It has 16 pieces of 1-inch square CCD, X-ray CCD. This is a main instrument. And this is a monitor of X-ray, solar X-rays. This sensor put on the top of satellite. Some details here, detail specification here, and energy range, and energy resolution, and cooling system, and total power consumption, and total mass. Total mass is about 20 kilograms. This is gamma ray spectrometer on board here. Yes, this is gamma ray here, covered by some sheet. And the specification is written like this. Detector is germanium, pure germanium crystal, and background scintillator with VGO and plastic scintillators. Energy range and the energy resolution system, especially we used Starling cryocoolers to get low temperature of 80 to 90 kelvins. So total weight about 50 kilograms. Very big instrument, I think. This is a lunar imager and the spectrometer systems. We called LISM LISM. This instrument also big, large instrument, 30 centimeter and 26 centimeter and 20 centimeter height. It includes terrain camera, stereo camera, and management imager, stereo imager, and the spectral profiler we have in these systems. This is lunar radar sound systems. Radar sound system has a high frequency of about 5 megahertz. And then the measures subsurface structures up to about 5 kilometers. This shows the gravitational field measurement systems. We used relay satellite to measure the orbit of main orbiter in rear surface, rear side of the moon. This is a measurement system. We use relay satellite and main orbiter and deep space antenna. So we use four-way Doppler relay satellite, main orbiter, and back to relay satellite and DSN antenna to measure the precise gravitational field of rear side. This is VLBI technique to measure the very precise gravitational field of near side. We make integration science by these so many data, and we have target of origin of the motion of the moon, and what is giant impact and what is compression of the moon, what is magma ocean. Yes, this is the magma ocean for hypothesis and giant impact hypothesis. And then we make clear these problems. That's our communication front. We use for ground stations. Yes. Science data will be open to the public 1 year after the termination of nominal mission from SOAC data center. Data handling system of about 10 terabytes data, such as the archive database and the retrieval system are implemented and tested now. This is our activities lunar exploration. First, lunar orbiter is 10. We call it 10. in 1990 launch. Then we have two sub-satellites to develop. One is Lunar. It is sorry to cancel. And now it's SELENE's KAGUYA. Now our community, science community, discussing the second SELENE follow-on missions. It may be landing in site observations. So we are discussing on SELENE 2 scenario and make preparation of technology. So this is cartoon of our SELENE 2 missions. This is candidate of landing site. We have a candidate for landing site. One is South Pole, the backside, and the North Pole, and big craters near site. We also discussed other planetary explorations, SELENE 2 and others. So that's a summary of KAGUYA has been launched successfully. We just finished first checkout of science instrument to confirm their fails. We expect science return very much. The main objectives and basic configuration of SELENE 2 are now under discussion. We plan to achieve this mission